Alrighty, let's see what we got. Okay, partition array such that maximum difference is k. I guess I've done this one before somehow. You're given an integer array nums and integer k. You partition nums into one or more subsequences such that each element in nums appears exactly once in one of the subsequences. Return the minimum number of subsequences needed such that the difference between the minimum and maximum values in each subsequence is at most k. Subsequence can be derived by deleting one or more elements. Return the minimum number of subsequences needed such that the difference between the maximum values in each is at most k. Okay, let's see an example. 36125, k is 2. So things inside the subsequences can be at most 2 away. We can partition nums into 2 subsequences, 3, 1, 2, and 6, 5. The difference between min and maximum in the first is 2 and 1. Since 2 subsequences are created, we return 2. It can be shown that 2 is the minimum number. 1, 2, 3, k is 1, 2. So like 1, 2, and 3, or 1 and 2, 3, I guess. And here it's k is 0. So you have to do 2, 2, 4, 5. Okay, I think this is just very similar to the last one, maybe. You just do a greedy approach after sorting the nums. So like nums, I sort the nums, and then just go through and for each element kind of extend the subsequence with that element up to the maximum kind of after it in the sorted order. It should be fine. So if I, for instance, sort this, see I'm like 1, 2, 3, 6, 5, 6. 1 is the first element in the first subsequence, and then since k is 2, I can do 1, 2, 3, and then next subsequence would be 5 and 6. Or here it's sorted already, so 2 can only go up to 2, 4 can go up to 4, and 5 goes up to 5. This is pretty straightforward. Answers the number of subsequences. So for every, let's say current is equal to the first element in the nums array. And then for every following element, for every following element, so value, actually for every value in the nums array that's sorted, if the value current plus k is greater than or equal to value, and that means I can still keep it. So continue. Otherwise, we're going to say that we've created one subsequence, and now this new value is the current. So current is kind of the lowest value in a subsequence in the latest subsequence. And so going through all the values that can be stored in it. If it's not able to be stored in it, then it creates a new subsequence. Not able to, if, actually maybe I can call this low. And then if the current value, which is value, is not within range of the low, then create a new subsequence. If current value is not within range of, within k range, so new. I guess I think the answer should probably start with 1 actually, since you already start with the lowest the subsequence. Oh, could be faster, huh? How could this be faster? Let's submit it again to see if it's actually a random variation thing. Although I don't think it is. Feels like it could be. So 93. Someone 68 is the cutoff. I think this is pretty darn. This is pretty darn good. Nums low value nums. An if statement. An increment. Setting. This is fine. Okay. So summary. This is purely. This one I would say. Using logic to that's it. This is kind of a greedy approach. I'd classify this. This is it's always optimal to put in as many elements or values into the current subsequence as possible. So starting with the low value, fill it up with as many values that are k that are within k of it. If once a value isn't, make the subsequence is as filled as possible. So start a new subsequence with that value as low, and then obviously need to sort the array to do this, to quickly iterate through values to put into parent subsequence. All right, and then this is going to be time complexity is O of n log n to sort the array, and O of n to do single pass through to determine count of subsequences needed. And the space complexity is O of 1 since sort is in place and no extra data structure was used. Yeah, I don't know why this would be considered a medium. I don't know.